Welcome to Chapter 11, Gas in Chemical Reactions. Please complete this review of Chapter 8's gas stoichiometry. If you have any questions about this, we have practice material in Chapter 8, and certainly you can ask me. When you have gases in chemical reactions, there's often two steps. You use the ideal gas law to convert the information that you have into moles. If you need to convert to another quantity in the reaction, you need to use stoichiometry. We have the Born-Haber reaction where hydrogen and nitrogen combine to make ammonia. How many moles of ammonia are formed by the complete reaction of 2.5 liters hydrogen? The temperature and the pressure are given. We are starting with hydrogen and we want to end up with ammonia. That tells us that the mole ratio is going to take place. But first, we need to determine how many moles of hydrogen there are. We cannot take the liters and change it to moles using 22.4 because it is not at STP. That can only be used at STP. That means the ideal gas law needs to be used to determine the number of moles of hydrogen. Pause the video and complete that part of the problem. We have 0.1055 moles of hydrogen. Since we need moles of ammonia, we'll need to use our mole ratio. Recall that the mole ratio comes from the balanced equation. If the balanced equation hadn't been given, you must write it. There are 0.070 moles of ammonia. There are 2 sig figs. Looking back at our original problem, the liters is 2 sig figs, temperature is 3, and pressure is 3. Since 2 is the lowest value of sig figs, that's how many sig figs the final answer should have. Pause the video and complete this problem. This time I start with the stoichiometry because I know I have kilograms of sulfuric acid. Changing the kilograms into grams, changing the grams into moles, using the mole ratio allows us to calculate the moles of oxygen. Although we have moles of oxygen, we cannot use the 22.4 liters per 1 mole conversion factor because it is not at STP. Using the ideal gas law, be sure to change the temperature into Kelvin and the pressure into ATM. Solve the rest of this problem.